Let us solve this problem to obtain the Fourier expansion of the function, which is f of x is equal to x over the interval minus pi to pi. And hence we'll reduce that into pi by 4, which is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, right? So let us solve this. Okay. Okay. Now here the function f of x, right, is x. Okay. Now let us check whether it is an even function or odd function. Now, since we substitute this as minus x, so this will be minus x, which is equal to minus of f of x. Now, if you look at this, the function is, which is f of x is equal to x, is an odd function, right? Okay. So in the question which is given over the interval minus pi to pi, so odd function over the interval minus pi to pi, right? Now we got the function which is an odd function, so therefore a naught will be 0, okay, and as well as an will be 0, right, for n is equal to 1, 2, and so on, right? And the Fourier expansion, which is f of x over the interval minus pi to pi, will be that is summation n is equal to 1 to infinity bn sine nx. Okay, and now let us find bn here, right? So bn is 2 by pi integral 0 to pi f of x sine nx dx. Okay. Okay. Now your f of x given function, which is an odd function, which is x. Let us substitute that here. So this will be 2 by pi integral 0 to pi x sine nx dx, right? Okay. Now let us integrate this and find what is bn. Yeah. So we get this as 2 by pi. So x integral of sine nx dx will be minus cos nx by n minus sine nx by n square, right? And over the interval 0 to pi. Okay. Now further, this is 2 pi, right? Let us separate this. Yeah, this will be minus when you substitute x as pi, so this will be 1 minus 1 by n, which is constant outside, and we have pi cos n pi, right? And the rest term will be 0 plus 0, right? Okay. Now this would lead to 2 by pi brackets minus pi by n, and now cos n pi will be minus 1 to the power of n, right? So this is 2 by if you cancel out pi here, we get 2 by n. This will be minus 1 to the power of n plus 1. So we got bn here. Okay, now let us substitute this and in this, let us substitute here, right? Okay, so our function which is f of x will be x, which is 2 summation n is equal to 1 to infinity minus 1 to the power of n plus 1 by n, right, into sine nx. Okay, this will be 2, okay, and sine x minus 1 by 2 sine 2x plus 1 by 3 sine 3x, okay, and so on. Okay, so now this is the function f of x is equal to x over the interval which is minus pi to pi, right? So we have to deduce this in pi by 4, which is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and so on. Let us deduce that here. Okay, now suppose we take x is equal to pi by 2, right? So I'll substitute it. So pi by 2 is 2 times of this is sine pi by 2 minus by 2 sine 2 pi by 2 plus 1 by 3 sine 3 pi by 2 and minus and so on, right? So if you bring down 2 on the other side, so this would be pi by 4 on the left hand side. Okay, so sine pi by 2, which is 1. Okay, so this is 1 and this term will be 0. We'll have okay, and minus 1 by 3, okay, and plus 1 by 5 minus 1 by 7 and so on. Okay, so this is the required expansion of pi by 4. What we got the expansion for pi by 4 here. Okay, now let us find the Fourier series for the function which is f of x, which is mod here. Okay, mod of x over the interval minus pi to pi. Hence, let us deduce that in pi square by 8, which is the summation n is equal to 1 to infinity, but that is 1 by 2n minus 1 whole square. Let us solve that now. Okay. Now, again, let us find whether it's an odd function and or an even function. Okay. Now, let us substitute here. It is minus x. So you get here as mod of minus x, which is mod x again, so which is f of x. Now hence the given function is an even function. Okay, since it is an even function over the interval minus pi to pi, right? Therefore you'll have bn as 0, right, for for this function which is f of x mod x. Now and the function f of x is mod x over the interval minus pi to pi. Okay, so mod x will be, that is, f of x is a naught by 2 plus summation n is equal to 1 to infinity an cos nx, right? Now let us find what is a naught here, right? So a naught is 2 by pi 0 to pi f of x dx. Now this is 2 by pi. Now this is x. So integral 0 to pi into x dx, which is pi. Okay, because f of x is mod x is x. Okay, for x greater than 0, right? So let us find what is an here. An will be 2 by pi integral 0 to pi, yeah, f of x cos nx dx. Okay, so this is 2 by pi integral 0 to pi x cos nx dx. Okay, now this will be which is 2 by pi x. This will be sine nx by n minus of minus cos nx by n square. Yeah, 0 to pi. Okay, so let us solve this further. Now this will be 2 by pi n square. We are taking the constants outside, and let us substitute this x as pi and 0. So that will be cos n pi minus cos 0. Okay, so which results to minus 2 n square pi. Now this is minus 1 to the power of n minus 1. Yeah, so we got an as 2 by n square pi minus 1 to the power of n minus 1. Okay, so now that we got an, let us substitute what is a naught and an. So the function f of x is mod x is pi by 2 plus 2 by pi summation n is equal to 1 to infinity 1 by n square and minus 1 to the power of n minus 1 and cos nx. Yeah, so this is equal to pi by 2 plus 2 by pi and 2 square, right, for n is equal to 1 cos x minus 2 by 3 square. Okay, cos 3x minus 2 by 5 square cos 5x and so. Okay, so brackets. Okay, we have got this. Now further, this would be pi by 2 minus 4 by pi summation n is equal to 1 to infinity 1 by 2n minus 1 whole square cos 2n minus 1 into x. Okay. Okay. Now further we have to deduce that also by let us substitute x as pi. Okay. Let us substitute this in the function f of x, which is x as pi. Okay, so this would be pi by 2, right, is equal to okay, and minus 4 by pi summation n is equal to 1 to infinity cos 2n minus 1 into x by 2n minus 1 whole square. Okay, now this would be pi square by 8. Okay, now so now we know that cos of cos n pi is cos n pi is equal to minus 1 to the power of n, substituted. So hence we obtain that as 1 by, and the summation n is equal to 1 to infinity 2n minus 1 whole square, right? So this is the required result which we found. Thank you guys for listening. Please do subscribe for more and more videos.